Hi, my name is Al Copeland. I'm with Evaporative Tower Service. We are the representatives of Baltimore Air Coil. We are currently standing up on the cooling tower compound on the roof of St. Joseph's Hospital, looking at the BAC Series 3000 and Series 1500 cooling towers. What we'll be going over today is a basic operation and maintenance of these cooling towers to keep them in proper operating procedures. First thing we want to talk about is the fill pack. How a cooling tower works is warm water from the building will flow from inside the building and is pumped up to the top of the cooling tower. It fills hot water boxes in the top, and that water is then cascaded down through these black PVC fill packs. As the water's cascading down, the fan on top is pulling outside atmosphere or outside air in through the louver face and cooling that water down. That water then lands in what is referred to as a cold water basin. It is then drained back down through that pipe at the bottom of the tower and is returned back to the building, to the chillers, and the whole cycle starts over again. The fill pack media will, over time, get fouled up, dirt and debris from inside the piping, dust from the air gets drawn in. All of that, with proper chemical treatment, will clean itself. What we do warn people, it's very tempting, is to grab a pressure washer and try and clean the fill pack because you see a calcium buildup or something like that. That is not good, especially once the fill pack gets a little bit older, gets a little bit brittle. A pressure washer and the PSI of a pressure washer will actually start blowing that fill pack apart. If you do see algae or calcium buildup within that fill pack area, what you really need to be doing is talking to your chemical treatment guy. Let him know, I see white calcium or I see a green algae building. He can adjust your chemicals and it will actually clean itself as the tower is running. As the water's down, running through the tower, the proper chemical treatment will clean those fill packs out all on their own. When you're doing your maintenance, and I will be providing you with the operation and maintenance manual that comes with these towers, it will talk about the intervals of inspection and cleaning. There's a whole chart that tells you what you should be doing monthly, what you should be doing quarterly, and what you should be doing annually. On the maintenance of this area, as we're still looking and talking about pressure washing, these louvers, these gray plastic louvers you see in front of the tower, their sole purpose is if there is any splash out coming from the fill pack, it will grab it and push it back into the tower so that we don't have water splashing out and over. Those louvers can be washed with a pressure washer. You should try and keep them cleaned up. That's an annual maintenance of a cooling tower. You wash off those louvers, try and keep them nice and clean so they don't break and fall apart on you. From this side of the tower, I want to move over to the side where we can have a look at some of the connections and safety features of the cooling tower. Okay, over on this side of the cooling tower, we have some of our connections and our electrical connections, as well as our access door to get into the cooling tower for some of the maintenance. Some of the things you have here is you have your emergency shut-off switch. If something were ever to go wrong with the cooling tower and you need to very quickly kill the power to the fan, you have an emergency shut-off here. Piece of advice on that switch, that's emergency use only. These towers run on variable frequency drives and don't like sudden losses in power. If you're going in just to do regular maintenance, always go into the mechanical room first. Once you're in the mechanical room, you'll shut everything off on the VFD. Then you can come out here, and as an added feature, you can shut this one off and put your lockout tag out here. Then you know you're pretty safe. It's not going to come on while you're working in the cooling tower. This line here, coming from below the tower, is your freshwater makeup line. Basically, as the cooling tower operates, we're pumping warm water to the tower, returning cool water back to the building. Just that process alone causes evaporation, and there will be loss of water within the tower. To maintain a proper operating level, we have a makeup valve that works internally. As the water level drops, it starts to make up water till we're back up to correct operating levels, and then it'll shut off. Next to this, we have a high alarm. This was an added feature to the cooling towers at St. Joseph's. It's a float assembly inside. As the water level rises, and if it reaches for whatever reason higher than what normal operating levels are, it'll trip that switch and send an alarm back to the building automation system to warn somebody, hey, cooling tower number 1 is operating at a critical level. It could overflow. We also have behind us here some gray piping. I'm going to take you over to this tower, as these 3 towers are identical, and it's a little easier to see from our vantage point. You have 2 gray pipes coming out. One that has a shut-off valve on it, and then another that just goes straight into the tower. These pipe down to drain. The top one is your overflow connection. Inside the tower, there is a set height where this pipe is piped into. If the tower ever reaches a critical level of water within the tower, it will just start overflowing and running that water down to drain. Below it, and basically mounted right at the bottom of our cold water basin, is our drain valve. We do want to do periodic maintenance, annual maintenance on these cooling towers, which will require them to be shut down. Individually, we can shut them down and drain them down and clean them properly. So when we're going to do a procedure like that, we can open up the drain valve. That will drain this sump down and allow us to get inside and clean any dirt and debris that might have settled within the basin of the cooling tower. Once we're done, we close that tower or that valve back up. Some of the towers are meant for winter operation, and some of them are strictly summer operation, which means in the winter they will be shutting them, isolating them, and draining them down. And when you do that, again, you'll be opening your drain valve and allowing the water to drain out of the basin. Once it's drained through the winter, if the tower is not going to operate, leave your drain valve open, because what will happen over the course of the winter is you are going to get snow, you're going to get rain, you're going to get sleet. That can access through the fan port at the top of the cooling tower, and it will accumulate within the basin. If you leave it closed, what will happen is that will start to build up, and then you're freezing and you're cooling and you're freezing and you're cooling. So if you just leave the valve open, anything that does accumulate in there will, by attrition, just drain itself out of the tower until you're ready to put it back online. These particular 2 towers we're standing in between are the 2 towers they've designated as their summer towers. The only difference between the summer towers and the winter towers are the winter towers have a built-in heater to keep them from freezing up. When we go down to have a look at the 1500 series tower, I'll show you those heaters. We've now moved down to the wall of the winter tower, just so I can show you the difference between the summer and winter towers. You'll see that there's some added connections on the side of the winter tower. Like the other tower, we have our high alarm tower. We also have a low alarm cutout switch. Basically, what those switches are designed to do is to warn the operators of the tower if a water level gets critically low within the tower. Maybe something's gone wrong with the makeup and it's not making up water fast enough. Why we're so concerned about low water in these cooling towers is twofold. First, the pumps, if the water level drops too critically low, the pumps inside the mechanical room will start to suck air and not get enough water, which will cause them to cavitate and loud banging. It's just not good. You want water levels up. It also is designed to protect the heater, and if you want to have a look right here, and added to this tower is a heater. It is designed to protect this tower through winter operation. When it goes offline, as the building load is not near as high as what it would be in summer operation, there will be a lot of times where the fans aren't running, the water isn't flowing, and this unit's just sitting with water floating within the basin. The last item on here that we didn't see in the summer tower is this gray box. Inside that gray box, if we were to open it up, is the thermostat. That thermostat just monitors the temperature of the water within the basin and keeps it at a 45-degree Fahrenheit temperature, which is just slightly above the freezing mark. And again, that's solely to protect the basin from freezing during winter operation. The next item, our next thing I would like to do is open up the access door and have a look inside at some of the things that we would be looking for when we're looking at these cooling towers as far as maintenance is concerned. Once you open the access door to the cooling tower, the very first thing you'll notice is that there's a service platform inside, which allows you to get inside and do work internally within the cooling tower. What we're looking at here right now is the motor and pulley assembly along with the belt that drives the fan in the cooling tower. The belt is a 5-groove system, and you should be always replacing it with a banded belt. The motor itself is on a slide base. With a wrench, you can either move the motor forward or backwards to loosen and tighten the belts. Belt tension should be checked on a quarterly basis. Just slightly above the motor, that's your vibration cutout switch. That is to protect the fan. If something were ever to fail and you can't get it to start, you should be getting an error code back at your VFD. That error code would indicate that the vibration switch has tripped. Once you've reset that switch and you realize, okay, the fan is now running again, you haven't fixed the problem. All you've done is been able to get the tower to run again, and you need to start diagnosing why did that trip. What we would want to do is to start bringing the fan up at very slow increments. What we're looking at here is the bearings on the shaft of the cooling tower. Those bearings have grease nipples on them. There's one at the bottom right here by the pulley, and then the other one's up closer to the fan assembly near the top of the shaft. Both those bearings should be greased on a twice-a-year basis. Couple pumps from a grease gun is all that is required to keep the bearings properly greased and extend the life of those bearings. The tower has a makeup assembly to keep fresh water within the basin of the tower. It's just a plunger system with a float ball on the end, and as the water level drops, the tower starts to make up water. As the tower level makes up and the plunger comes back up, the water starts filling. That is the heater that enters the cold water basin, and that's what keeps the basin from freezing in winter operation. Right next to it, there's a filter assembly. There is some buildup on it now. But what we need to do is on a monthly basis pull these filters out and just wash them off with a garden hose is usually all that you need to do, and then they just reinstall back into the side of the tower. The last place we want to do is go up to the top of the tower where we're going to have a look at the hot water boxes where the water enters the tower. We're now on top of the Series 3000 cooling tower. As you can see, what I'm standing on right now is a series of access doors. These doors are what allows you to get in and have a look at the hot water box inside the cooling tower. There's a series down this side of the tower and an identical set down the opposite side of the tower. The water that has been pumped up through the pipes we looked at earlier flow in through these pipes, enter the top of the basin or the hot water basin from the middle, and then disperses itself evenly across this bank of hot water box. Basically, as the water fills that basin, it drops down through those ports, fills the black fill media with water, and again, as we talked about, ends up down below in the cold water basin. Inside these boxes, the nozzles that flow will, over time, collect some dirt and debris as water's flowing through it. On a semi-annual basis, or twice a year, we should be opening up these boxes and just cleaning them out. Usually a shop vac is sufficient enough to be able to clean that dirt out of there, and it just allows for a good even flow across your entire fill media to ensure proper efficiency of the cooling tower. Over here you'll see our top view of our fan assembly. Just looking down, you can get a really good shot of that vibration switch we were speaking of earlier. If you ever need to do some major service on the actual fan assembly itself, this is how we would access the fan. We would take off this screening, and the fan would just pull out right through the top of the cooling tower. We do our maintenance and then reassemble everything back through the top. Over to my right, you're going to see the Series 1500 cooling tower. Basically, this 1500 series cooling tower is the baby brother of the Series 3000 we've been talking about up to this point. There is not a lot of differences between this tower and that one, other than it has a smaller fan. It only draws air through one side of the cooling tower. It all looks the same, but just in a smaller scale than the Series 3000 we've been talking about up to this point. It also has a hot water box basin on the top, just like this cooling tower does. We have our fan assembly. That is also set for winter operation. So down to the side, you're going to see that you got your makeup valve, you've got your high alarm, cutout switches, thermostats. It's all the same, and the maintenance is done exactly the same on that tower as you would on these 3000 series towers. We are looking at the PEP centrifugal filter. The sole purpose of this filter is to separate any hard solids within the water that are coming from the pumps and cooling towers and trapping them to prevent any of that reaching your chillers and pumps and causing premature failures. Basically, what we have is water flowing in from outside out of the cooling towers, pulled down through a pump assembly that you see right here below me. That is then flowed through this pipe into the centrifugal part of the cooling tower. As the water hits this, it starts to turbulate, spinning in a very rapid motion. Any hard solids that happen to be within that water will fall within this chamber and get trapped at the bottom of this chamber. Vice versa, the clean water then is flowed back out and is returned back to go through that whole cycle out at the cooling towers again. On the side of this filter assembly is the control panel. Internally, within this control panel, there really is no serviceable items. There are some switches that the operator needs to either turn on or off depending on what operation you want the unit in. Other than that, any failures within this box representative of the manufacturer needs to be contacted for service. So inside this box, you have your main power switch. It's either on or off. When the towers are in operation, this should always be in the on position so that we know and ensure that we're filtering the water properly. Down below you also have a motor control off and on. There is an area in this where you can actually hook it up to a remote sending system. This unit in particular hasn't been set up for remote, so we're only going to be concerned whether the motor is on or off. Once again, when the tower is in operation, we should always be in our on position. Next to it, we have a purge control, always set to auto. What the purge does is it prevents, or it does a self-cleaning of itself. How the purge control operates is it's constantly monitoring the pressure incoming into the unit, the pressure outgoing out of the unit. It's monitoring the differential between those two pressures. When that pressure differential reaches approximately 7 to 8 psi, the control board inside here is programmed to know that that's a very wide range of differential in pressure. It assumes then at that moment the unit is dirty and it needs to be cleaned. It does that itself. It puts itself into purge automatically. It stops the flow of water going back to the tower and sends it out the purge valve at the bottom of this tank. Any sediment on the bottom of this tower will be then purged out through this copper line and it's just sent down the drain. The purge will run approximately 30 to 40 seconds and then it will switch back to filter mode and the computer just starts to cycle over again. It starts monitoring that pressure differential. As it sees it climb, it will reset itself and put it back into purge mode and clean itself again. Servicing of the unit, there really is not a lot to do with this unit. We can manually look at the pressure differential. If you feel it's getting high, but maybe the unit hasn't put itself into purge mode itself, you can switch that valve from the auto mode into hand mode. In other words, by putting it in hand mode, it will just start purging itself. Keeping in mind, in hand mode though, it will purge until you tell it to stop. There's no time on hand mode. It will just purge continuously till you take it off of hand mode. Always make sure if you're leaving the area that you've switched that back to auto mode. If you find the unit purging on a continuous level, what I mean by that is it purges, it comes out of purge, and then almost immediately goes back into purge. That's because it's seeing a blockage or it's not liking the pressures that it's seeing. The computer is not. Good chance your problem is within this filter at the beginning of the filter assembly. To check this filter and to clean it, what we want to do is take the red valve, shut that off, turn the tower off, shut the pump off, put that into the off position. You can open up this valve at the bottom, will relieve a little bit of the pressure that might be built up in there, and then using a wrench, take the top off of that assembly. Inside there you're going to find a basket filter. What that basket filter will do is catch and trap any large particles that might be coming through the system before they actually get dragged into your pump and cause damage. The very first thing you should check is that that's clean. That probably on a normal operation of the tower is something you may only have to do on an annual basis. Beyond that, the unit is fully automatic. If you are shutting the systems down to do maintenance on the pumps or the filter or the cooling towers, pardon me, you should not leave this in the running positions. In other words, if you're not flowing water from the pumps, then don't run your filters because the pumps don't like to run dry. It wants to have water going through them all the time. Other than that, these would just be left on in the on position, and there is very little anything you can do as far as maintenance is concerned. I will be leaving on site a copy of the operation and maintenance manual. as well as an electronic copy will be sent to you guys so that you can have it for permanent records. We are currently standing in the mechanical room of St. Joseph's Hospital. We're about to talk about the PEP sand filter. This sand filter is designed and is used in conjunction with the cooling towers to filter any sediment that might happen to get washed in or through the cooling tower before it reaches the chiller and causes any damage inside the filter. The simplest way to think about how this filter functions is if you think of a filter on a swimming pool. You basically have the water entering the tower through a pump system, which you can see down right here. That pump then sends the water up and through an actual filter media. Inside this tank is a series of very small pebbles to start at the bottom up through sand media sitting on top of those pebbles. The water flows through that media and then back out of the filter, allowing it to trap any small particles, anything that might have come through from the cooling tower. This unit is fully automatic. Although we have a control panel on the front, that is all programmed at the factory, and there is actually no serviceable items inside this control panel. The only thing the operator needs to be concerned with is that the power switch is in the on position so that we know that we have power, and then down here we have the motor in the on position as well. That means the filter is running, it's doing its job, and there's not much more you can do with this. How the filter works is we have pressure gauges that are monitored by this control panel. What it's looking at is the pressure incoming into the filter assembly, and at the same time it has a look at the pressure of the water coming back out of the filter. As the filter is monitoring our incoming and outgoing pressures, and the filter, it gets a little bit dirty inside, the difference between the incoming and outgoing pressures will slowly grow further apart. After approximately 7 psi difference between the two pressures, the unit will automatically trigger itself to go into backwash mode. In backwash mode, the filter will actually clean itself. Once it's done backwashing, the computer within the unit will monitor those pressures again, and if the pressure differential is still greater than what it prefers to see, it will backwash again. Your only indication that something has gone completely wrong with the unit is if you come and the unit is constantly cycling back and forth from backwash to filter, backwash to filter, and never stops that cycle. At that point, you need to turn the unit off and determine what's wrong. The first and 90% of the time, the problem will be right in here. Right inside this cap, like a swimming pool, you have a little skimmer, our filter basket. It's collecting or catching any large particles before they make it into the filter. The very first thing, if a unit is stuck in that loop of backwash and filter, is to shut things off, turn your valve to the off position to prevent the water from coming, take the 4 bolts off the top of this, remove the basket, clean it, reinstall, and put the unit back online again. You also have a maintenance button on the front of the panel. It's labeled push for backwash. That's where you as an operator, even though it's not ready to backwash, you could press this button and force the unit into a backwash cycle all on its own. Again, this unit is fully automatic. There really is no reason for you have to do that, but the option is there if you need or feel the need that you need to do it. The last thing on this filter assembly is the actual filter media itself inside that tank. When this unit was put online earlier this year, brand new filter media was installed in the tower. there was also a spare set of the media sent with the tower, so that the next time you need to do the maintenance, you have it to do. If you ever have to replace the filter media, you would have to isolate the tower using the same valves I showed you down here to stop the flow of water. Then you would come over and open up the side port and the top port. That'll relieve any pressure that builds up in here. You would physically drain out all the water that's in this tower, and you would scoop out the old filter media. Once you have the old one out, rinse it with a hose, allow that to drain out, install your new filter media as laid out on the bag and in the operator's manual, and allow the unit to refill itself. It has an automatic purge valve on top, so as you're filling, any air that's trapped in here will be purged out of the top of the filter. And you can see they have a hose so that once it reaches full level, a little bit of water might squirt out. That just finds its way down to the drain. Again, fully automatic system, really not a lot of maintenance required. The inside of the control box is completely operation only. There's really no serviceable items inside. If the unit fails, you need to phone the PEP representatives and explain the situation, what is happening, and they can diagnose or get the proper people in to help you diagnose what's wrong with the control box. Beyond that, the sand media should last 2 to 5 years, depending on the amount of dirt, and based on that, it's more a judgment call. If the unit is purging itself on a continuous basis and that cycle seems to be getting more and more and more often, it's a good indication that the filter media is no longer doing its job and it's time to change it. Again, a good rule of thumb is approximately 2 to 5 years, depending on how often the towers run. I know the cooling towers here, half are going to be off all winter. That's going to extend the life of the filter media a little bit beyond that.